Good morning. Today's class is a continuation of yesterday's class, that is Laplace and Poissons equation problems. So in this problem, let us consider a semi-infinite conducting planes at pi is equal to 0 and pi is equal to pi by 6 are separated by an infinitesimal insulating gap as shown in figure. If V, that is V is equal to 0 at the condition of pi is equal to 0 and V is equal to 100 volt at the condition of pi is equal to pi by 6. Calculate E and V. So yesterday's solving problem, we have to calculate V, E, D, rho. After that only we can easily find out the capacitance of the infinite plate. That is the capacitance of the parallel plate capacitor C is equal to epsilon A by D. But in this problem, we can calculate only V as well as E. So the figure which is given in the problem, here x, y is at three region, x, y is a three dimensional. So it is a Cartesian coordinate system because it is the structure which is resembles it's a cylinder. So here it is clearly pointed out that it is grounded in this region, that is V is equal to 0. So here that is a pi naught, which is nothing but pi naught is pi by 6. At the condition of pi is equal to pi by 6, the voltage will be V naught, that is V is equal to 100 volt. Okay, these are the two boundary conditions. So pi is equal to 0, V is equal to 0, pi is equal to pi by 6 at the condition of V is equal to 100 volt. So for this cylindrical coordinate system, we have to find E as well as V. Since in this problem itself is clearly told that the cylindrical coordinate system is only depend on pi. So I already mentioned that for a cylindrical coordinate system, three coordinates are there: rho, pi, z. In this problem, rho is equal to 0 as well as z is equal to 0. Only pi seems to be changed from pi is equal to 0 to pi is equal to pi by 6. So since V depends only on pi, then the Laplace equation becomes del square, that is 1 by rho square dot del square V by dou pi square is equal to 0. So here rho is equal to 0 as well as z is equal to 0. So the rho 1 by rho square is constant value which goes to the right hand segment, it will be 0. So rho square V by rho pi square is equal to 0. So I already told that we have to find out the voltage. So we have to integrate the equation into 2 times, then we have to clear the V, that is voltage. So rho V by rho pi is equal to A. So then V is equal to A, which is pi is an unknown term, A pi plus B. So this is a final term. So by means of boundary condition, here there is two boundary condition. So one is at the time of V is equal to 0 and pi is equal to 0 at the condition of V is equal to 100 volt where pi is equal to pi by 6. These are boundary conditions. By means of boundary condition, we have to find out the unknown parameter A as well as B. So V is equal to 0 at the time of pi is equal to 0 where B is equal to 0 while substituting in the equation 1. So at the same time, while substituting the equation at V is equal to 100 volt whereas pi is equal to pi by 2, the unknown parameter A is equal to 100 pi by 6. Finally, A is equal to 600 divided by pi. While substituting A and B in the equation 1, B is equal to 600 divided by pi into pi plus B, which is nothing but 0. This is a final value of V. So we know that I already in the yesterday problem I already determined E is nothing but minus del V, negative gradient potential. So minus del V is nothing but tau V by tau pi. So which is nothing but a constant A. So here minus symbol. So minus tau V by tau pi, which is nothing but minus A. A is nothing but I already find out, which is nothing but 600 divided by pi. So E is equal to minus 600 divided by pi. So this is the easiest way to find out the electric field intensity, which is nothing but E, as well as voltage V, which is nothing but 600 divided by pi into pi for the cylindrical coordinate system. So here this problem is already we solved. So the next problem is about a cylindrical coordinate system. Here it's a simple figure, that is a simple pictorial representation. It consists of two cylinders, inner cylinder as well as outer cylinder. Inner cylinder which is having a radius of A, outer cylinder which is having a radius of B. The outer cylinder is grounded, that is the voltage is 0. Inner cylinder which is having a potential with having a magnitude of V is equal to V naught. So this is a boundary condition. It consists of two cylinders. Inner cylinder with a radius of A having an voltage of V0. The outer cylinder which is having a radius of B which is having an voltage of 0 because it is grounded. So first we have to write the cylindrical, that is Laplace equation for the cylindrical coordinate system. Why it is Laplace? Because in this problem they didn't determine anything about the charge density, so rho is equal to 0. So it is clearly resemble that it is a Laplace equation. So first we have to write the cylindrical coordinate system formula. So from that we have to know that rho is nothing but a radius r. Whatever may be rho or r, both are radius. R pi z or rho pi z. Both are same. So r is a radius of the cylinder. Since the problem is only depends on the radius of the cylinders, so pi as well as z is equal to 0. So the equation, that is 1 by r, tau by tau r of r into tau b by tau r is equal to 0, because pi is equal to 0, z is equal to 0. So we have to find the v. So 1 by r is a constant term while we going for the RHS, because it is a 0, so all becomes 0. So remaining tau by tau r into tau b by tau r equal to 0. So then the derivative part tau by tau r is, when we move towards the RHS side, it will become a 0. R into tau b by tau r. So when we going for the integrating, so tau by tau r which is going to integrate one side, so then it will become a constant value a. So r into tau b by tau r is equal to a. So r which is moving towards RHS, that is right hand side. So tau b by tau r is equal to a by r. So we'll be going for integrating this equation one times. We can easily find out the voltage. So V is equal to A into 1 by R becomes log R plus a constant of B. So this is a final equation of the voltage for the cylindrical coordinate system. V is equal to A into log R plus B. So boundary condition we already know. So voltage is equal to V0 at the condition of R is equal to A. Voltage will be 0 at the condition of R is equal to B. Okay. So then V0 is equal to A log A plus B. So while we moving towards substituting all the equation, finally we can easily find out the A as well as B. So by substituting this A and B in the equation 1, finally we can find the voltage. So this is a voltage, that is an unknown voltage inside the cylindrical coordinate system. So V0 divided by log A by B plus log R by B. So R is a radius, A and B the unknown term. For the same, it is a spherical coordinate system. R is equal to A at the time of V is equal to V0. R is equal to B at the time of V is equal to 0. So this is this assignment problem that you have to solve with the help of this answer, and you should post it in the Google Classroom. Thank you.